this video we will discuss how to write exponential functions given 2 points. Given 2 points, we can write an exponential function using 3 very distinct steps. If we're given 2 points, we can use 1 point to solve for a using the general form y equals ab raised to the x. So using one of the given points that we have, we're asked to solve the general equation, or the general form y equals ab raised to the x, for a. Second step, using the other point in the value of a, we can solve for b, using the general form. So now, at this point, you should have a numeric result for b. Now, what we're going to do is we're going to plug that numeric value that we just found for b back in to the equation we found in step 1 and solve for a. And then the final step, the third step, write the exponential function using the values of a and b that you just derived in the general form y equals ab raised to the x power. So now let's try an example on how to write exponential functions given 2 points. In this first example, we're given the point -2/16 and 1/1/4. First step, we're going to use the general form y equals ab raised to the x power and one of the points, and we're going to solve for a. It doesn't matter which point you choose. I'm going to choose the first point because it's a little bit nicer. It doesn't have any fractions in it. And wherever I see a y, I'm going to replace it with 16. Wherever I see an x, I'm going to replace it with a -2. So we get 16 equals ab to the -2. The first step said we had to solve for a. Well, to solve for a, divide both sides by b to the -2 power. And you get a is equal to 16 over b to the -2. We have a negative power in the denominator, so all that does is just bring it right back up to the numerator. We're left with a is equal to 16 b squared. This, when we solve this for a, this is going to be very critical when we actually find out what the value of b is. We're going to come back to it. So now we have our value of a. Now we're going to use the other point in this value of a and solve for b. So in their general form here, y equals ab raised to the x. Wherever I see a y, I'm going to replace it with a 1/4, and wherever I see an x, I'm going to replace it with a 1. And now since we solve for a, we're also going to replace a with this expression here. So we have a 1/4 equals 2 ab to the first power. Remember, I'm going to substitute this value of a, this value, or this quantity 16b squared, in for a. So I have 1/4 equals 16b squared times b. We have a b squared times a b. That's just going to become a b cubed when you add the exponents. You get 1/4 equals 16b cubed. Now it just comes down to a little bit of algebra and solving for b. First steps, divide by 16. Divide both sides by 16, that is. We're left with b cubed equals 1/4 divided by 16. And when we divide 1/4 by 16, that's really saying the same thing as b cubed equals 1/4 times 16. And when we do that, we get 1/64 equals b cubed. And the last step is we have to take the cubed root of both sides. And when we do that, we're going to get b is equal to 1/4, because the cubed root of 1 is 1, and the cubed root of 64 is 4. So our value of b is 1/4. So now, what we're going to do is we're going to use this expression here for a and solve it for a given our value of b. So our value of a is equal to 16b squared. And now we're just going to substitute 1/4 in for b. We get a equals 16 times 1/4 squared. If you think about that, that's really the same thing as a is equal to 16 times 1/16. And we take 16 and 1/16 and multiply them together. We're going to get a is equal to 1. So now we know our values of a and b. So now using our general form here, y equals ab dx, we can just substitute those values back in to our general form. We know a is 1, so if y equals 1 times 1/4 raised to the x. And if you wish to write it just as y equals 1/4 quantity to the x, you may do so. It's mathematically equivalent. So just to recap what happened, we took our general form and 1 point, in this case it's negative 216, and replaced the x's and the y's as needed, and solved for a. In this case, a is equal to 16b squared. Then, using this value of a and the other point, we solved for b. Wherever you saw a y, you replaced it with a 1/4. Wherever you saw an x, you replaced it with a 1. And then wherever you saw an a, you replaced it with the expression 16b squared and solved all the way for b. And then, since we know our b value, and we know what our value a is equal to from step 1, you could substitute b in, 1/4 in for b here, likewise, and found our a value is equal to 1. And just then, after that, just took these values of a and b that we found and substituted them back into the general form y equals ab to the x to get y equals 1 times quantity 1/4 raised to the x, or y equals 1/4 quantity to the x. Next example, we're given the points 1, -5, and 4, -625. And we want to find an exponential function that includes these 2 points. Remember what the general form is, y equals ab to the x. We're going to take 1 point, I'm going to take 1, -5 first, and just substitute the values in. Wherever I see a y, I'm going to replace it with a -5, and wherever I see an x, I'm going to replace it with a 1. And at this step, I'm just going to solve for a by the first step. Just solve for a. Divide by b to the first. And we're left with a is equal to -5 over b. Second step, we have this a value, and then we have this other point here, 4, -625. I'm going to use the general formula, just make substitutions as needed. So wherever there's a y, I'm going to replace it with -625. Wherever I see an a, I'm going to replace it with -5 over b. And then there's our b term. And wherever I see an x, I'm going to replace it with a 4. So then when I take this away, do the algebra, we have a b to the 4th. If you want to think about this you can think about it as b to the fourth over 1. In this case, there's going to be some an exponent in the numerator and in the denominator. If you want to write it as negative 625 equals negative 5 b to the fourth over b, you may do so. But then notice what's going to happen. We have b to the fourth over b to the first. Remember, by exponent rules, division means you subtract 1 from 4. And you're left with a b to the third. So that expression now becomes negative 625 equals negative 5b cubed. And now it's just a matter of solving for b. Divide both sides by a negative 5. And you get b cubed equals 125. Then when you take the cubed root of it, you're going to get b is equal to 5. So there's our value of b. Now we can plug this value of b back in for a. So we have our value of a is equal to negative 5 over b. In this case, wherever there's a b here, we're going to replace it with a 5. So we have a equals negative 5 over 5. And a negative 5 over 5 just gives us a negative 1. So now we just found our value of a and our value of b. Now we can plug these back into our general form. And that becomes y equals negative 1 times 5 to the x. And if you so choose to write it a different way, you can write it as y equals negative 5x, or you can write it as y equals negative 5 to the x. Personally, I would rather write it as y equals negative 5 to the x. That way you can differentiate between where the power is actually being applied. In this case, the power is actually being applied to the 5 first, and then you do the multiplication by the negative. So just to review what happened, we took one of the given points, in this case 1, negative 5, and wherever we saw an x, we substituted in a 1 in. Wherever we saw a y, we plugged in negative 5. Likewise, we did here. And then just solve for a. We get a is equal to negative 5 over b. Then using the other point for negative 625, we plugged in x. Everywhere we saw an x, we plugged in a 4. Wherever we saw a y, we plugged in a negative 625. And wherever we saw an a, we plugged in negative 5 over b. And then just by doing some algebra, we were able to find b is equal to 5. So then we had our values of a and b, and we were able to just plug those back into our general form to get y equals negative 1 times the quantity of 5x squared, or y is equal to negative the quantity 5 to the x power.